Today, we're going to tackle a massive question. Can we really trust an AI with our lives if we have no idea how it thinks? We're going to explore this whole idea through one of the trickiest logistical puzzles in all of medicine.
Okay, so let's just jump right in. We're talking about blood platelets. They are absolutely critical for things like cancer treatments and stopping major bleeding. But here's the catch. They have a super short shelf life, just 5 days. That's it. And for hospitals, this creates a constant, massive headache. You have to imagine, every single day, blood bank managers are walking this incredibly thin line. If they order too many platelets, this precious donated resource just gets thrown out. It's a huge waste. But if they order too few, well, that could lead to a critical shortage, and that puts patients in real danger. It's an unbelievably intense balancing act. So, could technology be the answer here? Well, this is where the idea of an AI co-pilot comes into play. Something designed to help people make smarter, faster decisions when the pressure is on. The specific kind of AI we're talking about is called reinforcement learning. And honestly, the best way to think about it is like you're training a puppy. The AI agent makes a choice, like how many platelets to order. If that leads to a bad outcome, like waste or a shortage, it gets a penalty, a little bad dog. But if it makes a good call, it gets a reward. It literally learns from trial and error. So the whole point of this is to let the AI run millions of simulations. And through all of that trial and error, it starts to figure out the perfect strategy, the best policy for ordering platelets that avoids those penalties and keeps everything running smoothly.
Now, on the surface, this sounds amazing, right? The AI gets fantastic results. But this brings us to a huge, fundamental problem that's at the very heart of AI safety today.
We can see that the AI works, but we have no clue why. It's a black box. The AI has cooked up this incredibly complex strategy that even the people who built it can't fully understand just by looking at it. And when you're talking about medicine, that's a really big deal. And as the source material for this explainer says, this opacity is a major problem. I mean, think about it. How can a hospital manager trust a recommendation from an AI to, say, slash an order if they have no idea what logic is behind that decision? You can't just blindly follow a black box. So to fix this, researchers came up with a way to crack open that black box. You can think of it as a formal audit, but for the AI's mind, letting us actually verify its logic and understand its reasoning. The tool they built is called CoolMC, and its job isn't to change what the AI learned, but to analyze the strategy it came up with. It's kind of like a diagnostic program designed to make the AI's thinking totally transparent and, most importantly, trustworthy. So here's the rundown of how it works. First, the AI gets trained like normal. Then, CoolMC basically creates a giant map of every single possible decision the AI could ever make. With that map, it can actually calculate the exact probability of a bad outcome, like a stockout. And finally, it can help us understand why the AI does what it does. So, what did this big audit actually show? What does an AI trained to manage something so critical really care about the most? Well, the answers are pretty eye-opening. First things first, let's talk performance. The audit confirmed that over a 200-day stretch, the AI strategy would lead to a hospital completely running out of platelets with a probability of just 2.9%. That is a really solid safety number. And what about the other side of that dilemma? Wasting this precious resource. The chance of the inventory being totally full, risking that waste, was even lower, just 1.1%. So yeah, the AI is doing a fantastic job at that balancing act. So, the numbers look great, no question. But this is where the audit gets really cool. What is the AI actually focusing on to get these results? What's its secret sauce? So, the audit revealed something totally fascinating. To figure out the AI's priorities, the researchers basically took away its toys. They hid certain pieces of information from it. And when they removed data about the freshest platelets, the ones about to expire, the risk of a shortage just skyrocketed. We're talking over 1,000%. This tells us the AI figured out that the age of the inventory is the single most important thing, way more important than anything else. Okay, this is a huge step. We now know what the AI values most. But to truly trust it, we also have to understand how it uses that logic in a real situation. So the audit noticed that a pretty common move for the AI was to order 14 units of platelets. This happened in about 12% of all the situations it faced. This gave the researchers a perfect test case to poke and prod its thinking. So they asked a classic what-if question. What would happen to safety if, In every single one of those situations where the AI wanted to order 14 units, they forced it to only order 6. That's a pretty massive cut. What do you think would happen?
Well, the result is genuinely mind-blowing. Basically, nothing happened. The stockout risk barely moved. It went from 2.90% to 2.87%. Slashing the order size in all of those cases had pretty much zero negative impact on patient safety. How is that even possible?
And this, right here, is the big aha moment. The reason the risk didn't go up is because the AI had learned an incredibly sophisticated rule. It only ever placed those big 14-unit orders when the inventory was already so well stocked that a smaller order would be just as safe. It built its own safety buffer into its logic. And just like that, we can understand not just what it does, but how it thinks.
All right, let's zoom out and think about the big picture here. This whole experiment goes way, way beyond just managing platelets. This is really about how we build a future where we can confidently lean on AI in the most critical parts of our lives.
So why does this matter so much? Well, for one, it shows we can actually prove an AI is safe before we deploy it in a real hospital or a power grid. It proves we can finally get past just looking at the final score and actually understand the reasoning, the how, and the why behind an AI's choices. This whole thing is basically a blueprint for building AI systems that we can actually trust, not just in medicine, but in pretty much any high-stakes field you can think of.
And that brings us to the final question. We started with this very specific problem, platelets that go bad in 5 days. But we've ended up with this powerful new ability to literally audit an AI's brain. So if we can do this for our blood supply, what's next? What other complex, maybe even life or death decisions are we now ready to trust to a machine that we can finally understand?